Hi, everybody. Thanks for joining to watch my little presentation. I'll offer a small apology because originally it wasn't meant to be me speaking. It was meant to be Tanmay, the CEO of Hasura, but stuff is pretty crazy right now, so he had to bail, and I've stepped in because I'm the local Aussie representative from the company. Even though I'm not in Sydney, I'm closer than he is, which is usually in San Francisco or in Bangalore, India. Just a tiny bit of background about myself. I'm an engineer over at Hasura. I only joined quite recently in February, so I'm still kind of learning a few things about the product, but it's an exciting place to be. There's a lot going on there right now. I kind of got into the GraphQL stuff about last year, I think. The previous company I was at was doing a lot in the AI space, and we decided to kind of switch from a RESTful approach to a GraphQL approach, and it was just awesome. So we started using GraphQL for all the data and all of the kind of API access for data scientists and stuff like that, and I think everyone had a great time. So off the back of that, I've leveled up and joined a pure kind of GraphQL company, which has been great so far. What else can I say? I've got a bit of a background in some data engineering style stuff, and especially functional programming. I actually run the Haskell meetup in Melbourne. And that's another reason why I think Hasura is a pretty cool place, is because a lot of their backend code is actually written in Haskell, which is pretty unique kind of developer experience if you've never had the joy of working in that language before. But that doesn't really make any difference to people who are using the product, because you don't need to worry about what it's written in. You just need to consume the GraphQL. Moving on. So what is Hasura? I think maybe there was a talk last year about this, so this might be rehashing, but I'll just briefly kind of go over what Hasura is. In a kind of very simple exaggeration or simplification, it's kind of like a Firebase on top of Postgres style product. So you can take any Postgres database and get like an instant GraphQL API on top of it, which is pretty useful if you like using Postgres already, and pretty flexible as well, so it doesn't tie you into anything. It's completely open source, so you can self-host if you want, and there are third parties that you can host it on as well. Tonight I'll show you it running on Heroku, which is one option to get it up and running instantly. One thing that actually kind of amazed me about the product is often I see kind of like the sales pitch from these kind of things is like, oh, it's so easy and so simple. And I was doing a demo for a client, and I needed a little GraphQL API really quickly on top of a Postgres database. And I just kind of Googled it, and Hasura popped up. And it kind of made a lot of promises. And I'm like, well, here we go. It's obviously not going to be this easy. And I just did the Docker run, and everything was like running in 15 seconds, no joke. So I had a great time, and it lived up to the promise, which is excellent. Other things about it, it's very fast. So it's very performant, both in terms of actually just throughput and serving up stuff, but it also optimizes quite efficiently the queries that actually hit the database. So if you do a lot of kind of manual resolver logic and stuff yourself, you might find that it's very easy for the kind of costs to balloon out and the number of queries to increase quite a lot. This kind of takes care of that for you as much as it can, and it's very nice. It's also, besides just being a layer on top of Postgres, has some additional functionality. So it can do kind of aggregation style things. So it can aggregate like upstream GraphQL APIs into a single unified API. You can kind of support what it calls actions, kind of like wrapping up RESTful APIs And it can also work as kind of like an event streaming backbone for kind of like microservice style architectures. And that plays well when you want to integrate kind of business logic rather than just data consumption. Also, another big feature is that it natively supports the kind of subscription capabilities to let you build real-time applications very quickly. As well as the core functionality, it's got a great community. There's a kind of vibrant collaboration on GitHub. There's a very active Discord server, and there's great kind of documentation and resources. So if you want to learn more, just go to the main website. It's hasura.io. And go to /learn if you want to find some more information out. And you can find everything from there. Yeah, I was originally going to run everything from Heroku, but streaming my schema over there was taking a bit long for some reason. So we'll see if it's finished. Oh, it actually has finished. Unbelievable. So I've got a local one running as well, which I might show off, but I'll just kind of show you what it looks like to spin it up initially. So if I go to Hasura, right on the homepage, you can find a link to do a quick start from Heroku, and that'll actually take you to one of these kind of magic apps that Heroku supports, which will essentially just spin you up a Postgres and a Hasura instance so that you can hit the ground running in a couple of minutes. I've already done this, so I won't do it twice. Where are we? That's my local one. Here we go. So yeah, so once you spin it up, you can jump into the console like this, and it'll just consume that database URL. Automatically. You can also do it, like I said, with Docker. So if I go to this is how I'm running my local copy. I don't know if you can read that. I'll make the font a bit bigger. So you can just use a little Docker Compose file if you want to also get the database. If you've already got a database, you don't even need a Compose file. You can just run it straight with Docker, which is what I did the first time I played around with it. And it really is kind of very, very straightforward and simple to get up and running. What I might show first, let me just get my slides again, is playing around with one of these sample data sets. So I'm not sure if anyone's familiar with the Chinook data set. It's just kind of like a bunch of artists and albums and music stuff like that, really. So we use that a lot in our demos just because it's reasonably self-contained and it's non-trivial. There's like a fair amount of data in there. If you've we might get some people to call out some of their favorite artists or songs and see if they're in there. I don't know that it's completely comprehensive, but it's got a fair few in there. If I go to the one on Heroku, I'll show you first something trivial, and then I'll show you working with that data set, right? Let's create a table, right? So rather than just doing stuff with GraphQL, there's also a few other interfaces into Hasura for working directly with your database. So that will include things like table creation and all of your kind of schema modification style stuff. So in this case, I'm sure you can see I've already got test table. We'll make this one test table 2, how about? And there's a lot of kind of like quick start functionality built in. So you can auto-complete some like commonly used, columns and things like that, which is quite useful. And let's have a new column in here that I'm going to call foobar, and we'll make that text, and it can be nullable, why not? And then let's add that in. So now we can see we've got two tables here. These are just the tracked tables. You may have other things in your database and you have to kind of explicitly decide whether they're going to be tracked in Hasura or not. So over to the graphical interface. I'm sure that everyone's familiar with graphical. There's a neat kind of like query builder capability here. So I'll just get rid of that. And that'll let us kind of select some data which currently is empty, right? So jumping back in again, I'll just insert some data with the raw kind of method right now. So we'll say testing. Great. And then if we go back to graphical, we'll rerun the query and we can see that that's popped up there. So that's kind of like almost the most simple way that you can use Hasura, is to kind of use it as a tool to set up some tools, insert data, and then be able to query it through your kind of GraphQL methods. These, as you probably saw, are all kind of like automatically generated. So the schema is derived automatically from the database schema. There are some other tools that do this as well. The Hasura kind of approach is pretty well thought through. So they've covered most of the kind of use cases that you'd want to kind of use day to day, I'd say. I believe recently they might have got in alpha relay support as well. So if you use relay a lot, that should be very helpful. So yeah, you get your queries out of the box. You also get your mutations. You get a bunch of kind of aggregations. You get filters, limits, offsets, all of the kind of stuff that you would kind of expect to find useful. So here's an example of adding a filter. So if we say that foobar starts with, I think we said it was T. So if we run that, we should get the same thing back. But if we say it starts with X, T, well, you don't get anything. So hardly any kind of surprises, which is nice. Most things kind of work quite intuitively, especially with the kind of query explorer on the left. I often end up using this as a prototyping tool or as a kind of exploration tool, even for existing APIs, just via the upstream mechanism, just because it feels so expressive to put stuff together here. So rather than just hacking your queries together inside your code base, I'll often do it here and then copy and paste them over to my code when I'm using it, in situ in the actual application, just because it's quicker to actually build the queries here. What else can I say? Yeah, as well as that, there's subscription support. So if I run this as a subscription, that should actually run in the background. Now, can I copy that link? If I paste this here, I hope you can see the whole screen there. And then if I insert a new row, and in this case, I'll call it XT something or other, you can see the subscriptions updated on the right. That's just kind of using the kind of normal WebSocket subscription capabilities that you'd expect. This console isn't doing anything special. So you can connect Hasura to any kind of like standard application that you would expect, like Apollo or anything like that, just works out of the box. Okay, what was next? Slides. All right. Yeah, so let's actually import this Chinook database now. So that might take a little while on Heroku. I'm not sure how long it's going to take. So we'll see how it goes. It's almost instantaneous on my local machine, but it can take a little while on Heroku. So let's track that as well. So this is what I was describing in terms of explicitly tracking your existing schema. There's a little interface that'll show you what's in your schema that has or hasn't been tracked, and then you can actually decide to, you know, kind of bring it into the fold, so to speak, with the click of a button, which is nice. But also, actually, more importantly, it doesn't do it automatically. So there's nothing that's going to be exposed that you don't want to be exposed. As well as a lot of these user interfaces, there's also a CLI that's available, so you can do this stuff programmatically and kind of like via a more migration feeling workflow as well. So for kind of experimentation, prototyping, and exploration, the UI is actually very good. But yeah, if you're kind of using it in a more kind of production context, there's a lot of kind of CLI tools and things like that, and formats and APIs that you can use instead. So yeah, we've tracked all our tables and foreign keys. So now if I hop over to the Explorer again, rather than just those test tables, you can see all of these kind of music-related pieces of information. So actually, let's do a query, not a subscription. So if we say, let's have a look at all of the artists, and we'll just get their names, right? So someone tell me like a moderately obscure artist that shouldn't be in here. We'll see if they've got it.
The Midnight.
The Midnight. Is that 2 words?
Yep.
Okay. Oops. I can't type when I'm screen sharing. They're not there. Yeah. So as I was saying, like that data set's like, it's got maybe like 5,000 artists or something like that, but certainly there'll be a ton in that it doesn't have as well.
Surely Rick Astley might be in there.
Sorry?
Surely Rick Astley is in there.
Rick Astley, yes, please.
Be very let down if he wasn't.
Oh my God. Rick Astley might not be in there.
Can't even get group Rickrolls to happen.
We'll have to Rickroll ourselves. Yeah, it's definitely not in there. All right, anyway. Yeah, so now that we've kind of imported these foreign keys, that'll demonstrate the ability to kind of do relationship traversal. So in this case, we've got the artists. You can then kind of get their set of albums, all the tracks. Like, I guess I'm preaching to the choir here, but like, this is just awesome. Being able to do this kind of thing with GraphQL really is a game changer. So I think basically you won't be surprised in the fashion in which kind of Hasura exposes that functionality. It's just the totally kind of standard way, but it kind of derives it all automatically from your database schema. So where are we? Let's see. Yeah, some of the ways that you might see some aggregations. Where are we? There we go. So there are some kind of fields exposed that have like a aggregate suffix, and that'll let you get some aggregate information. What's the count? Have I done something wrong here?
Oh, there.
Let's say aggregate count. That's better. Must have left off a brace or something like that. Yeah, so there are a few kind of aggregates exposed in this fashion. You can also apply your filters to these to these aggregates the same way that you would with queries and things like that. So that's actually very useful, having that come out of the box. I know when you're kind of authoring resolvers to do this kind of thing manually, just covering all those edge cases that developers might kind of expect becomes a major pain. So having those kind of all available out of the box is definitely a major time saver. Oops. Sorry, I just paused by accident. Yep, also mutations, unsurprisingly, available in the same fashion. So let's run a mutation. Too many deletes. Here we go. Insert artist 1. Oh, how about Rick Astley? Right, now Rick is in there. I think also I should be able to show the history of these queries. So, somewhere I should be able to see Rick Astley. There we go. Great. So this is all kind of like, I guess from a GraphQL kind of usage perspective, is not particularly surprising. That should just be business as usual. Some of the other things that you can do is you can actually kind of traverse relationships in your filter clauses. So that's quite useful and maybe surprising that that comes out of the box. But it's this example here. So that's quite nice to be able to say, I want all the albums where the artist's name starts with A or something like that. Basically, you can go to any arbitrary depth you want there, which is really nice, actually. It might also be interesting to see that you can jump into a kind of SQL analysis tab here. So if you're trying to optimize performance and things like that, it's very nice to be able to jump straight from a GraphQL query to an SQL statement along with the execution plan. Especially if you're traversing a lot of relationships, it can be really nice to see just how optimized that ends up popping out. So a lot of these kind of tools are exceptionally useful for getting to that kind of like production mindset and scaling mindset with your applications. Okay. So, also, yep, you've got your docs and schema available. I've shown off the subscriptions. I showed the data updating from a subscription when we were importing a row. Obviously, that carries across in this data set as well. So another thing that's actually a little bit unique about Hasura is how the permissions system works. So if we actually go over to our data, let's have a look at the artists table here. You can see there's a few tabs along here, but one of them is permissions. And so the way that Hasura has kind of implemented its permission system is kind of like a row level permissions where you can have kind of like quite sophisticated predicates that can traverse relationships, right? So let's, oh, it's role-based as well, right? So if we introduce a new role here, we'll call it the artist role. And then we'll allow artists to select. They can't do anything else. And we'll have a check and we'll say the artist ID is equal to the user ID, which will be sent through in a special header. Okay. You can also add kind of additional restrictions on what they get back, including kind of column sets, you know, row limitations and things like that. But let's just start with that. Then back in our user interface, we'll add a couple of headers. So we'll call it X Hasura role is artist. And I believe the other one was called X Hasura user ID. Maybe it was 1, maybe it was 2, I can't remember. So let's just start from the artists table, and we'll get name. Yeah, great. So now if I'm selecting all artists, we actually only get back the ones that match our user ID. So that's hopefully not too surprising what's going on there. But obviously this kind of functionality is quite powerful because it's operating at the row level. So if we go back to the artists kind of view, let's now go to albums and see if we can do another kind of piece of permissions for albums. So we'll say, like, if you're an artist, you want to be able to select an album where, well, in this case, it already has the artist ID, but let's pretend it didn't. We'll pretend it had the artist through some other mechanism. The artist ID is, oops, not equal to, no, equal to the user ID. So you can see we're just kind of traversing one relationship here. And in this case, it's a trivial one that you could have skipped anyway, but you can see the mechanism. So once again, we'll allow you to select those columns. And then back here, you should also see the schema, the Explorer updating at the same time. So now, as an artist, you're restricted to just seeing albums and artists. And then everything should kind of work as you would hope it would work. So we'll have the name, albums, and oops, title. And there you are. Wow, one of my favorite albums of all time. Great. So how are we going for time? I think we've got about 10 minutes left. Okay, so now let's have a look at two of the kind of integration capabilities. One's called Upstream Schemas, and another one is called Actions. There's actually a third one, which is Events, but I didn't build an example for that, but maybe we can try and see what one might look like, because I think we can do that with HTTP bin. So, remote schemas. So what I've done in advance is I've put together a little Heroku app that just does a little trivial piece of kind of nothing work and returns a little bit of data. So it's just a kind of like proof of concept. So I'll show you that now. I originally was going to demo this on Glitch. I don't know if you know Glitch. It's one of those kind of like community collaborative coding things, which I really loved, but it's just stopped working today. So at the last minute, I've had to try and rejig all this for Heroku. So anyway, we've got a tiny little kind of Apollo server here. So all it's going to do is essentially kind of have one resolver, which is going to return kind of a hello world thing. So actually, I'll revert this so it just says hello world. And let's see if that works. Hopefully I haven't broken anything with my yarn.look. And we'll see if that works. The only reason why I'm redeploying this actually is because I forgot the URL which it's living on. So this will tell me when I redeploy. But it should also serve as kind of proof that it's really running there. Not that you wouldn't believe me. Launching, there we go, great. So back here, I probably already actually had it here. I did too. There we go. Yeah. Right. So yeah, in this case, I've got that one schema that I just added called Aqueous Meadow that's going to serve up our little hello app. The important thing to know about it is that it'll just kind of put everything in the kind of top level namespace. There's a new feature being released soon so that you can explicitly decide to namespace all of your upstream APIs however you want. But currently it kind of puts everything at the top level. So if I now go back to my graphical, you should also see that exposed, provided I turn off my role, exposed here with the hello field. And if we have a look at our kind of query documentation, can I search? Yeah. So if we have a look at the query documentation, like all of the kind of regular GraphQL capabilities are exposed through this upstream interface. And I found some surprising uses for this actually. Once I needed to build an app to do do a bunch of statistics on app signal data for a kind of financial report. And trying to build that through app signal interface itself was next to impossible, and doing it through like just a bunch of curl and stuff like that would have been annoying as well. But via this upstream schema capability that Heroku has, in conjunction with being able to kind of inject whatever auth headers I could pull out of my inspect network tab, I actually was then playing around directly with AppSignal's GraphQL API, which was very, very nice. And that let me put together this report very quickly. So that was a kind of surprising use case that I found was like a happy surprise. Yeah, so I mean, I'm not doing much in this example really. I'm just returning the data, but actually there are ways that you can kind of make that a little bit more interesting. So I haven't checked actually exactly what I'm doing here yet, but yeah. I see. In this case, actually, I don't think the functionality is exposed to do the joins here, but you can do it via the actions, which I'll show you in a sec as well. So as well as the remote schemas, which is kind of a way of integrating external GraphQL APIs, you can integrate REST APIs through what they've called actions. So actions are kind of a way of wrapping up your REST APIs or third-party REST APIs that you might want to kind of integrate with your application and exposing them through the same GraphQL interface. The way that you kind of do it is by defining a couple of types for basically for your inputs and outputs and any kind of related nested types you might want. Then defining a new kind of mutation that exposes this, this action as a field. And then you point it at the actual kind of host that's going to handle your action. And then you decide whether it's going to be sync or async. So this was added recently, especially in a kind of like microservice context where you have a large kind of chain of, you know, sequential kind of propagation of a kind of user interaction. You will find that kind of doing everything synchronously is an absolutely horrible idea because you get enough services and something's eventually going to time out. So making that asynchronous now is just a click of a button, which is very nice. You can also kind of do webhook style forwarding if you want. But that's like nothing too interesting there. Where it gets quite interesting is that then you can build relationships. So you can kind of integrate that REST API as if it was a native part of your GraphQL schema and allow you to join on it and things like that, which is very useful. So I wish I had one of these actions up and running for you right now, but I didn't manage to get it going in time. I had it in Glitch, but Glitch is not working. But I can show you briefly what it might look like in getting up to at least the part where you get a response. So it gives you a little bit of code gen demonstrated as well that you can use for your, to put into whatever environment. In this case, it's just Node. But you know, you can translate that into whatever kind of framework that you're working in. Once again, you can add permissions to your actions. Yeah. So back in Graphical, I should be able to run. Oops. Never type when someone's watching. Here we go. So all it should really return is an access token. And it takes an arg of password. Username. So this actually should throw an error in its response because the response that HTTP bin is giving back in this case doesn't match the expected format. So that's actually quite nice. That marshals that into a kind of errors array that you might expect to deal with. So even though I wasn't actually demonstrating the action here, task failed successfully, if you know what I mean. But you get the idea. Like if the response had have matched the format here, you know, you'd get back what you expected, and you could even kind of reconcile those fields with foreign keys or whatever relationship you want to reconcile. So that's kind of like how you would set up an action like that. Apologies that that's not getting past the final hurdle there. Another thing that you can do is what's called events. So this is kind of intended to be essentially a way to kind of like stream new records in a table to any other kind of services that might want to kind of know about that stuff. So in a kind of microservice framework, this can be a very quick way to get up and running, which is very nice. So let's create an event. So in this case, let's just go with artists again. And we'll get, we'll just do inserts for now. And in this case, we can use HTTP bin because it's not going to mind too much what the response is. So there's also a bunch of kind of advanced settings that you can put on, but let's just ignore that for now. One of the most obvious is headers if you need some secure information to propagate. So now this will actually have a kind of corresponding log of the events that you can come back and look at if you want to look at it. But let's insert an artist and show what that does. What was that artist that you mentioned before? Started the
Midnight.
The Midnight. I'm going to have to look this up afterwards. Okay, let's just get the ID back. So no surprise that gets inserted okay. But now if we have a look at our test trigger, we'll actually see there's a row in here. And you can now kind of expand that out. Look at the payload. You should also be able to look at the response, which maybe is more interesting. So if you've got a kind of microservice style setup or serverless setup, sorry, I should be saying serverless more. That was in part of the talk description. So if you've got a Lambda consuming this, you can actually kind of use this to do a little bit of kind of tracing and debugging of what's going on from your inter-service communication, which is just kind of invaluable if you've ever kind of been in a situation where all of your data is just disappearing off into a black hole and you're not sure what the hell's going on, then yeah, just being able to click a button and see what happened is just amazing. So yeah, that's quite useful. So I guess that is kind of concludes the integration discussion. So yeah, we've covered the upstream schemas, actions partially with broken response, and events. So hopefully that gives you a little bit of an overview of some of the things that make Hasura a little bit different from some of the other ways that you might work with GraphQL. Certainly, like the highlights that I'd want you to kind of take home are it's instant, like it works just out of the box on top of your either existing or new Postgres. And it comes with a lot of kind of like features that you would wish that you have, but probably wouldn't want to build them all yourself. And thirdly, it's got a lot of kind of ways to integrate with other services. So that's probably the top takeaways. Just before I sign off, I know I'm running a tiny bit over time. Yeah, go to the website, try it out. It really is like very quick to try. We've got a Discord if you want to chat to anyone, if you've got any questions. There's a bunch of the people who work at Hasura, including myself sometimes on the Discord. So it's just /Hasura. And then finally, starting today, we're actually kicking off HasuraCon 2020. And it's all online because of the apocalypse. But yeah, so you can check that out. I believe the actual talks start on the weekend, but you can sign up for workshops right away, I think, which are starting today. And there's all sorts of great stuff there. I won't try and enumerate everything, but if you go to just the Hasura website, you'll be able to find a link to HasuraCon. So thanks for listening to my talk. Oh, and do we have time for any questions, or should I hand it over?
Yeah, no, absolutely. Yeah, does anyone have any questions for Lyndon?
Yeah, I do. Absolutely. Hasura looks awesome. I'm really quite impressed by how it's grown, I guess. I think we first saw a demo at GraphQL Sydney about a year ago. It seems to have come a long way since then. But yeah, it looks great. One of the questions I have is how easy is it to preserve your GraphQL APIs without breaking it when you migrate the database? So let's say, for example, you have to do something which involves, I don't know, renaming a column. I don't know why you'd want to do this. It's a contrived example. Let's imagine you rename a column in a table, but you want to make sure that API clients that already exist don't break. How do you handle that?
Yeah, that's actually a great question. So I will kind of like apologize in advance if I kind of give you guys any misinformation here, because I haven't been working there super long, so I might not know the answer to all of these questions. But my understanding is that there isn't like very in-depth support for kind of API compatibility measures at present. We are introducing more and more of them, like the ability to kind of alias columns, like you said, and things like that over time. But I think basically, if you've got a kind of fairly substantial API, especially with any kind of non-standard resolver behaviors, Hasura doesn't try to kind of provide a compatibility mechanism for that.
Okay.
I think who knows what the future will hold, but like at present, you have to match your maybe not exactly your database schema, but you have to at least kind of match that paradigm in order to use it.
Okay.
So probably if you were going to do a migration activity, you'd probably want to tackle that some of that migration work on the existing API first, and then on the Hasura after. Or potentially put in a kind of gateway that would do some of that compatibility work.
Okay. I have one more quick question, unless anyone else would like to go before me.
Go ahead.
So how does Hasura boot up? Does it need to interrogate the database schema when it starts, or can it have that pre-cached? What I'm trying to get at is it fast enough to be used in a Lambda function? Could I serve a GraphQL API from a Lambda using Hasura?
Yeah, that is something I wish I'd tried before. I've never tried to use it in a Lambda. My intuition is that it probably is fast enough if you've got a kind of, not a kind of like instantaneous Lambda result, but I would guess it might be fast enough. The binary comes up to about 30 megs or something like that, I think. So I've seen Lambdas doing more work than that. And your other part of your question, yeah, you can kind of like pre-define your schema. It doesn't need to kind of interrogate that and build that itself from your database schema. It does cache that inside what we're calling like a catalog table. So it will at least need to interrogate one query, but it certainly won't need to kind of like, spider through your entire database in order to kind of do any work. That's for sure.
All right, that's pretty cool. Thank you. I have no more questions.
Thank you. Who was asking the question, by the way?
Oh, James.
James. Thanks, James.
Anyone else got any questions for Lyndon?
I had a question.
Go ahead.
Limitations on taking existing schemas. What are the sort of the highlights of the things that it can't do?
Do you mean in terms of like what kind of exotic schemas might it not support?
Yeah, exactly.
That is a good question. I think.
I mean, just things like JSON blobs, and there's obviously lots of weird stuff you could potentially do, but not be supported, because I guess you guys aren't magic.
Yeah, it's certainly not magic, and I'm sure there are some examples of especially like exotic data types that are probably not super well supported. But one of the kind of things that is relatively magic about how it works is that Hasura doesn't actually try and do too much data munging on the response. So actually kind of the magic of Hasura is that it kind of acts like a compiler as opposed to like a data flow engine. And so it tries to do as much work in the query itself as it can, as opposed to getting loads of data back and then processing it and then sending it to the client. So in terms of getting a response from the database to the client, that's relatively transparent. And one of the advantages of that is that it you know, delegates most of the kind of work to Postgres, right? So most of the stuff that you would expect to work in Postgres also works in Hasura. Like I said, I'm sure there are cases where that's not true, but you would be surprised at where it does work. So you've seen, like we've seen people using it with kind of PostGIS style scenarios and with timescale DB and things like that. So, you know, it'd be good to see a kind of list of things it doesn't work with, but you might be surprised in what it does work with.
Yeah, it would be really good to see. I don't know if it's already on the website. I've been trying to find a list of the Postgres core types that Hasura can handle and which ones it can't. So if it's not there already, that's a good suggestion to put on the website, is a list of the core Postgres types that Hasura has mappings for. That would be pretty cool.
Yeah, that's a really good idea. And who was asking the question, by the way?
Someone else was, I think, wanting to ask a question.
Oh yeah, I had one question, which was actually, I think, sort of answered actually in that previous answer. It was around the optimizations, because I've done a bit of work with like the data loader side of things for around GraphQL because of the n+1 problem, because we have like recursive like looping queries. But I see Hasura as a really good way of potentially solving that at a query level where, you know, the query itself could be completely optimized. Assuming that Hasura takes a lot of that under the hood. You kind of answered that in your previous answer, actually. But yeah, it's actually quite entertaining. An immediate use case that I'd like to see, I'm just curious about, like from a stack point of view, do you guys have an example of, say, something like running Hasura on Fargate with Aurora? Because I've not looked into it a lot, but if off the top of my head, I'm just looking at it going, that's a pretty scalable, fast solution, like infrastructure solution.
I've heard those words before, Fargate and Aurora, but I think it's in the dim memories of the back of my mind. Are those like, you know, scale databases or something?
No, oh, sorry. Okay, so Fargate is literally just AWS's container solution that is like non instance based. So it basically, you can just specify, hey, I want X number of containers, and they'll just give it to you without you having to specify EC2s under the hood to run them on.
Oh,
and Aurora is essentially just their rerun on traditional databases, but incredibly scalable and good for, like, especially for read replicas, like the ability to have multiple read replicas. I believe they're using the S3 engine under the hood, but they've just made it Postgres compatible on top. I was actually just curious. I'm just cheating to see if you guys had like a cheat sheet somewhere where I could just pull this and try and stack it up.
Yeah, I'll share a link to my slides, and if I find the answer, like if there is a kind of tutorial on that use case, I'll share that. But I think the answer is that that's definitely kind of possible to take advantage of if it's Postgres compatible, because we've constructed this to essentially kind of be like a stateless layer, right? So basically, you should be able to kind of scale it horizontally as much as you want, with very, very few exceptions. Like, it really doesn't need any kind of synchronization capabilities. So as long as your query doesn't need to scale to multiple instances and can go through a single instance, then I think it should work very well. We do have some caching kind of capabilities built in. They're meant to be transparent caching. So yeah, if you've got a round robin, you might lose some of that advantage. But if you've got like sticky session style, you know, load balancing, then you shouldn't even lose the caching advantages.
Awesome, cool. Yeah, because I was going to follow up with just a WebSocket scenario, which, yeah, you just answered with the sticky caching. Yeah, cool, awesome. Thanks, man. That's great talk and cool product.
And what was your name, by the way?
Chris.
Chris, thanks. Thanks, Chris.
No worries. Thanks for talking.